Auzubillahiminash-shaytanir-rajeem. Bismillahir-rahmanir-rahim. Dear students, Assalamu alaikum. Dear students, in this first video lecture of week 10 for the course Differential Equations, today we are going to learn about the solution of higher order linear differential equations. So, first of all, I would like to tell you about the higher order linear differential equations and its solution. Now, higher order linear differential equations. The nth order linear differential equation with constant coefficient. The differential equation of the form a naught d ny divided by dx power n. This term means nth derivative of the function y with respect to n times x plus a1 d power n minus 1 into y divided by dx power n minus 1 plus a2 dn minus 2 into y divided by dx power n minus 2 plus and so on an minus 1 dy by dx plus any is equal to x, where x and the coefficients a0, a1, a2 up to an are constants are function of x. If x is not identically 0, then this linear differential equation is said to be non-homogeneous, whereas the equation a0 d power n into y divided by dx power n plus a1 d power n minus 1 into y divided by dx power n minus 1 plus a2 dn power n minus 2 into y divided by dx power n minus 2 plus and so on plus an minus 1 into dy by dx plus any is equal to 0. This equation obtained by setting x is equal to 0, and if x is equal to 0 in this linear higher order linear differential equation, then this equation is said to be associated or related homogeneous equations. For example, the equation dx cube y triple derivative with respect to x plus 3x square y double derivative with respect to x minus 2y dash mean dy by dx plus 6y is equal to sin x. This is non-homogeneous linear third order ordinary differential equation, because in this right hand side x not equal is equal to 0, but if the x function is 0, then this equation will be homogeneous. Similarly, suppose you see over here d triple derivative of y function with respect to x minus dy dash y dash mean dy by dx plus dy is equal to 0. This is homogeneous linear second order differential equation. Now, how to find the solution of linear higher order differential equation with the constant coefficients? So now we are going to discuss the procedure for the solution of homogeneous linear differential equation with constant coefficients. Consider the nth order homogeneous linear differential equation with constant coefficients. You see over here a0 dny divided by dx power n plus a1 dn minus 1 into y divided by dx n minus 1 plus a2 dn minus 2 into y divided by dx n minus 2 plus and so on plus an minus 1 into dy by dx plus an into y is equal to 0. Its symbolic form is f of d into y is equal to 0, where the function of d is equal to a0 d power n plus a1 d power n minus 1 plus a2 d power n minus 2 plus and so on plus an minus 1 into d plus an is equal to 0 is linear differential operator. Simple is that this capital D is equal to d by dx. This is called the differential operator. And now we write the auxiliary equation of the linear differential equation f of m is equal to 0. So now this equation can be written in this form: a naught m power n plus a1 m power n minus 1 plus a2 m power n minus 2 plus and so on plus a n minus 1 into m plus a n is equal to 0. Now to solve this auxiliary equation, dear student, you see over here this m is the root of this differential equation. So in this differential equation, m is the root. So suppose if m1, m2, mn, m3 up to mn are the nth root of this auxiliary differential equation. Now the question is that here a question to be arise: how to find this root for this linear differential equation of higher order. These roots take different forms as follows. Number 1, if the roots are real and distinct. Number 2, if the roots are real and repeated. Number 3, if the roots are complex and distinct complex, and if the roots are complex and repeated. So there are 4 cases for the roots of higher order linear differential equation. For the roots of this auxiliary equation, there are 4 cases. Roots take 4 cases. So in this lecture today, we are going to discuss only this one case when the roots are real and distinct. Then the auxiliary equation solution form will be in which form. So first of all, find the roots of this auxiliary equation, then we can find the solution of this linear homogeneous differential equation of higher order. Dear students, one point should be noted that the linear differential equation of higher order has 2 solutions. One solution is a complementary solution and the other solution is a particular solution. But since in this lecture we are considering only the homogeneous part, so the homogeneous part take only the complementary solution. So first of all, find the roots for the complementary solution, then we will make the form of complementary solution. So now first case, if the roots are real and distinct, m1 does not equal to m2, m2 does not equal to m3, m3 does not equal to mn, and so on, then the complementary function, the complementary solution will be equal to c1 e power m1x plus c2 e power m2x plus c3 e power m3x plus and so on cn e power mnx. So this is the complementary solution for the homogeneous linear differential equation of higher order. Now for example, to find the general solution of the homogeneous linear differential equation of order 2, y double dash mean d square y with respect to 2 times x plus 5y dash minus 6y is equal to 0. We can write this equation in this simplest form: d square plus d minus 6 into y. D square mean d square, second order derivative of the function with respect to x, and d mean first order derivative of the function with respect to x, and taking y common in this homogeneous linear differential equation of order 2. Now the auxiliary equation will be in the form of m square plus m minus 6 is equal to 0. Now to factorize this algebraic, this is a simple algebraic equation. To factorize this algebraic equation to find the roots m, so m square plus 3m minus 2m minus 6 is equal to 0. We can take factorization of this polynomial by sum and product. So taking common m from these two terms, m into m plus 3, and taking common minus 2 from these two terms, minus 2 into m plus 3 is equal to 0. Now this equation can be written as m minus 2 into m plus 3 is equal to 0. Now if we consider if m minus 2 is equal to 0, the product of these two factors equal to 0 means that m minus 2 will be either will be equal to 0 or m plus 3 will be equal to 0, or one of them is equal to 0, and we can consider that these two also equal to 0, then the product of these two factors will be equal to 0. So m minus 2 is equal to 0 implies that m is equal to 2, and m plus 3 is equal to 0 implies that m is equal to minus 3. Now you see over here the roots are real and different, so the complementary solution for this homogeneous linear differential equation now can be written as yc complementary solution is equal to c1 e power m1 x plus c2 e power m2x. Now putting just the value of m1 and m2, we obtain the solution yc complementary solution is equal to c1 e power 2x plus c2 e power minus 3x. Now the second example, to find the general solution of this homogeneous linear differential equation of order 3 with constant coefficients. You see over here the coefficient of this term is 1 and the coefficient of this term is minus 1, so the coefficients are constant. And now this equation can be written as d cube minus dy d cube minus d into y is equal to 0, and the auxiliary equation of this differential equation is m cube minus m is equal to 0. Now to find the roots m for this algebraic equation, taking m common, m into m square minus 1, and this implies that m into this is the formula a square minus b square, which can be written as a plus b into a minus b. So m into m plus 1 into m minus 1 is equal to 0. Now this expression can be written as m1 is equal to 0, m2 is equal to 1, and m3 is equal to minus 1. We have three roots: m is equal to 0, m is equal to minus 1, and m is equal to plus 1. So there are three different real roots. Now the auxiliary equation, the auxiliary equation has the complementary solution, that this differential equation has the complementary solution c1 e power m1x plus c2 e power m2x plus c3 e power m3x. Now putting the values of m1, m2 and m3, we obtain c1 e power 0 plus c2 e power 1x plus c3 e power minus 1x, and the solution is now in the simplest form c1 plus c2 e power x plus c3 e power minus x. E power 0 is equal to 1. 1 multiplied c1 obtained c1. Now in the third example, to find the general solution of this third order linear differential equation with constant coefficients, a d cube minus 3d square plus 2d minus 6 into y. Now the auxiliary equation for this differential equation is m cube plus 3m square minus 2m minus 6 is equal to 0. Now to factorize this auxiliary equation, to find the roots for this equation, take m square common from these two terms. We can write m square into m plus 3, and taking common minus 2 from these two terms. Minus 2 into m plus 3 is equal to 0. Now this equation can be written as m plus 3 into m square minus 2, and now m plus 3 into m plus 2 m plus under root 2 into m minus under root 2. This is equal to 0, and now the roots are m1 is equal to minus 3, m2 is equal to under root 2, and m3 is equal to minus under root 2. So you see over here the roots are real and different. So the complementary solution for this homogeneous differential equation now is equal to c1 e power m1x plus c2 e power m2x plus c3 e power m3x. Now putting the values of m1, m2 and m3, c1 e power under root 2x plus c2 e power minus under root 2x plus c3 e power minus 3x. In these three roots, we can take m1, m2 and m3 any roots. So the complementary solution you see over here is equal to c1 e power under root 2x plus c2 e power minus under root 2x plus c3 e power minus 3x. Now another example, fourth order linear differential equation, third order linear differential equation of third order linear differential equation with constant coefficients d cube minus 5d square plus 4 into y is equal to 0. And now the auxiliary equation, this is actually the fourth order linear differential equation. Fourth order linear differential equation with constant coefficient. M4 minus 5m square plus 4 is equal to 0. This is the auxiliary equation for this fourth order linear differential equation. So to find the roots of this auxiliary equation, we can factorize as in the form of m power 4 minus 4m square minus m square plus 4 is equal to 0 by sum and product. Now taking m square from these two terms, m square into m square minus 4, and taking common minus 1 from these two terms, minus 1 into m square minus 4 is equal to 0. So we can write now m square minus 1 into m square minus 4 is equal to 0. Now by formula a square minus b square, we can write this expression as a minus b into a plus b. So m minus 1 into m plus 1. And again, applying the formula a square minus b square for this expression, m minus 2 m plus 2 is equal to 0. Now if m minus 1 is equal to 0, then this implies that m is equal to 1. And if plus m plus 1 is equal to 0, then implies that m is equal to minus 1. And if m minus 2 is equal to 0, then implies that m is equal to 2. And m plus 2 is equal to 0 implies that m is equal to minus 2. So you see over here, there are actually 4 roots, and all these roots are real and different. So the complementary solution for the differential equation, fourth order differential equation, is equal to c1 e power m1x plus c2 e power m2x plus c3 e power m3x plus c4 e power m4x. Now putting the values of m1, m2, m3 and m4, we obtain c1 e power x plus c2 e power minus x plus c3 e power 2x plus c4 e power 2x. Now dear students, the conclusion of this lecture, note the conclusion of this lecture. Actually in this lecture, our topic is a solution of higher order linear differential equation. This is the higher order linear differential equation. But dear students, note that this linear differential equation of higher order have different form. One form is that sometimes these coefficients a0, a1, a2 are constant and not the function of x, and this right hand side x function will be 0. If this right hand side function x is 0 and all the coefficients in the left hand sides are constant, then the equation will be homogeneous linear differential equation of higher order with constant coefficients. So the higher order linear differential homogeneous equation with constant coefficients can be solved by this formula, by this procedure. First of all, write the auxiliary equation. The auxiliary equation have root m. Find the roots of that auxiliary differential equation, and the roots can take different 4 forms. Sometimes roots will be real and different. Sometimes roots will be real and repeated. Sometimes roots will be complex and different. In the last 4 times, roots will be complex and repeated. So if the roots are real and different, then the complementary function will be c1 e power m1x plus c2 e power m2x plus c3 e power m3x plus and so on plus cn e power mnx. So dear students, again I would like to tell you about the higher order linear differential equation. If this right hand side function x is 0 and the coefficients a0, a1, a2 up to an are constant, then the equation will be homogeneous linear differential equation of higher order with constant coefficient. In this case, the equation have only complementary solution. For the complementary solution, first of all, write the auxiliary equation of the homogeneous linear differential equation with constant coefficient, and then find the roots, and after finding the roots, check the nature of the roots. Nature of the roots have take different four forms, so the complementary solution also will take four different forms. But in this lecture today, we have only discussed the case when the equation is homogeneous with constant coefficients and the roots of the auxiliary equation are real and different. Then the complementary solution can take the form, this form, c1 e power m1x plus c2 e power m2x plus c3 e power m3x plus and so on plus cn e power m and x. Now if the roots are real and repeated, then this complementary function will take other different form, and for the complex roots, complementary solution have other different form. So another one case for this higher order linear differential equation, if this x function not equal to 0 and all the coefficients are constant, or if all the coefficients are the function of x, but if this x not equal to 0, then the equation will be called a non-homogeneous linear differential equation of higher order. Then for the non-homogeneous equation, the general solution contain two solutions. One is complementary solution and other is a particular solution. So inshallah, in next lecture we will discuss second nature of the roots. Roots will be real and repeated. Then what will be the form of complementary solution? Now this is the end of this segment. Thank you. Allah Hafiz.